Now, we spent a whole chapter factoring quadratics, yes? Okay, so now we're going to factor polynomials, which means a little bigger than quadratics, okay? Let me remind you of some techniques we used when we factored. We had, specifically the special patterns we had a difference of two squares, where if we had two things that were both perfect squares, how did we factor them? A, somebody's saying it, A, come on guys, plus B times A close minus B, okay? So if both numbers were perfect squares separated by a minus sign, all right guys, if y'all will put everything up, I see some phones, I see some computers, y'all put everything away. So let's say I had x squared minus 25, are those both perfect squares? Yes, so how does it factor? It doesn't matter which one comes first. And then x plus 5, right? And so this was just a pattern that you had to memorize, right? So we're going to talk about another pattern that you just have to memorize today. Yes?
It doesn't matter if I do x plus 5.
No, the order doesn't matter because you can do multiplication in any order.
Is this going to be on the test?
Yes. All right. Now, guys, I'll wait on y'all because I'm not going to fight y'all to teach you. These were based on powers of 2, which means raised to the second power, right? 2 to the second power is 4, that's a perfect square. 3 to the second power is 9, that's a perfect square, and so on and so forth. The pattern that I'm going to show you today, or one of the patterns I'm going to show you, is a sum and difference of 2 cubes. So we have to think about what a cube is. Y'all got this? Now remember, if it's perfect squares, it's only difference of 2 squares. You can only have a minus in the middle. But if it's cubes, okay. Cubes. Tell me first of all, what's a cube? Power of 3. Give me an example of a cube. 3 cubed, which would be 27. 27 is a perfect cube. I'm going to go up here and add the 2 one. What's 2 cubed? 8. 2 times 2 times 2 would be 8. Does anyone know 4 cubed? Good job. How about 5 cubed? How about 5 cubed? 125. Are you doing those in your head or you know them? How about 6 cubed? $216. Calculator. Okay? You need to be able to recognize at least up through here. Not so much know them off the top of your head, but know that, hey, wait, I think that's a perfect cube. Okay? Here's what happens. If I've got 2 numbers that are both perfect cubes, and right now I'm just going to call them A cubed and B cubed. Okay? Remember, with squares, it could only be minus, but with cubes, it can be a plus or a minus. If they're both perfect cubes, the way I factor it is this. Y'all ready? Okay. It's the same pattern for both of them, but it's a little intimidating when you see it the first time. All right. Do a little parenthesis big enough for 2 terms, and then do a big parenthesis big enough for 3 terms. Little parenthesis, big parenthesis. Now we're going to fill in our signs first, okay? And there's a pattern. We do same, so whatever you started with, same, change, but the end always has to be a plus. Same change plus every time. Okay? So look at the second one down there, the a cubed plus b cubed. What are the signs going to look like for that one if you follow that pattern?
Okay, you say N or N?
Plus, minus, plus. Say again, Grayson.
You say N or N?
Where?
Like the plus.
It always ends with a plus. All right. So y'all said plus, minus, plus. Same change plus every single time. Remember, this is more about memorizing the pattern. Same change plus. Okay? Now we're going to fill in the first parenthesis first. You're going to take the number that multiplies by itself 3 times to give you this. So in this case, it's just A. Right? If that was a 27 sitting right there, what would this number be? 3. Okay? If this was a 125 sitting here, then this number would be 5. It's what to the third power? Huh? What? You with me? Same with the B. I'm giving you a general form now, and then we'll do one with numbers in there, okay? All right. First number, or first term, goes in the first spot, squared. The last number goes in the last spot, squared. And the middle multiplies them together. Same change plus, and then you use this first parenthesis to write the other. You can either or. Let me show you an example. Y'all got this? You need a second. Okay. Tell me when you call. Let me give you an example. Let's say I have x to the third plus 27. Do you see the pattern? Yes. What's the pattern? 3's is the sum of cubes, right? Okay, yeah.
So let's replace the cubes.
Yes, we're still there. All right, so set up your parentheses first. Little parenthesis, big parenthesis. What do the signs look like? That's right. Same, change, plus. Does that confuse anybody? Okay, look at the first set of parentheses. What times itself 3 times gives you x cubed? X. What times itself 3 times gives you 27? 3. Do we all see where those two numbers came from? All right, now let's use those two to form the next piece. What goes here? X squared. You square the first one for the first spot. What about the last one? What goes in the last one? 3 squared or 9. How about the middle? 3x. You see what I mean by it's just a pattern? No? 3x, you multiply these two together and put them in the middle. So the first one squared goes in the first spot. The last one squared goes in the last spot. And then the two together goes in the middle. Yes. Okay? Let's do another. Well, there's there's a grouping, but we've really already grouped. We're just going to group with an extra term. Let's do, I don't want to make it hard just yet. Let's do, we will be. That'll be the next step. Let's do 16x to the 5th minus 250x squared. Now, I showed you the pattern first, but there's something that we always do before we factor. What is it that we do? We look for something. What'd you say here?
Like common two numbers?
What about a common number? What about the common? What are we? Somebody said it. GCF. The GCF. We look to see if we can take something out of both of them. So looking at this, do these two terms have a GCF?
Yes.
2? I heard 2. 2. I can divide both of these numbers by 2. How about the variables? Can I take any variables out?
Yes.
How many? 2 x's also, right? Do we all agree that's the GCF? Remember whenever we talked about GCFs? The biggest thing you can divide both numbers by and the most of the variables you can pull out. What is left in the parentheses if I take that out? 8 cubed do we all see that? Some of you are looking very confused.
You're probably great something back.
Okay, look. The GCF here. The GCF, the greatest common factor of 16 and 250 is 2. That's the biggest thing you can divide them both by, right? But I also want to take away any variables that I can while I'm here. So if you think about this one has 5 x's and this one has 2. Remember, this is where we backwards distributed, so we took them out. Instead of distributing and giving it to them, we took them away. So because this one has 5 and this one has 2, then I can actually take 2 of those away from both of them. So when I take 2 x's away from here, it leaves me with 3.
Okay.
Yes.
So the x squared doesn't have to go in 5 anymore?
No. Only the number in front. Does that make sense now? Yes, ma'am. Yes, you subtract the exponents and you divide the numbers in front, guys. I know. Okay, does that make sense, Hayden? Okay. Did y'all all hear that? You subtract the exponents, guys. You divide the coefficients, the numbers, okay? Now look at what's in parentheses and tell me what you notice about those two terms. You can do the thing, they're both cubes. Let's see, 2 to the 3rd is 8. 27, 64, 125, there they are, they're both on there. So let's set up our parentheses. It's a difference of 2 cubes, okay? The 2x squared stays. Little parenthesis, big parenthesis. What are my signs going to look like? Somebody said minus, same change plus, right? Same change plus. First parenthesis, what's going to go here? What times itself 3 times gives you 8x cubed? 2x. Right? I got to have the x in there too because there's 3 x's there also. How about 125? Y'all follow me? Take the first one and square it. But square the whole thing, not just the x. What do you get?
4x squared.
Yes. You got to put the squared on the x, and you got to square the number in front. So 2 times 2 is 4, and then x squared. The last one, what does it become?
10x squared.
The last one, 25, 5 squared. How about the middle, 10x? Uh-oh, John, that's not a good look. That,
Excuse me. What did the square on the 25?
if you want to write it as 5 squared, you can. I just went ahead and I know 5 squared is 25.
Well, with 2x, we did 4x squared.
Right, so because I don't know what x is, so I just have to give the squared. The squared's only going with the x here, not with the 4.
I just want to know how you got from 8x cubed to 2x.
Okay, because we're looking for 3 things that multiply to give me 8x cubed. So I know that 8 is 2 to the third. So 2 times 2 times 2. And then if I put an x on each one, 2x times 2x times 2x gives me 8x to the third. Remember those exponent properties? We add these exponents. 2 times 2 times 2 is 8, x to the third. Shh, guys, y'all focus, focus. Say again, John.
And same with 125.
Yep. And I'm using this list to help me too. Let's do another. Sorry, y'all. Anybody tell me what to do? Micah? Ah. You're really close, actually, though. You're really close. And this is kind of a trick question. Does anybody see it? They're both perfect squares. So I've got, this time, instead of a difference of 2 cubes, I've got difference of 2 squares. How does it factor? All right, look, because you've got to be able to keep these straight and see the difference in the patterns, which is why I threw this up here, okay? These are both perfect squares, not perfect cubes, so it factors differently. What if it looked like this? Would it?
No, because it's a plus.
That's right. It's a plus. You can't, it would have to be a minus. It would have to be a minus. So this one, the way it is, yes. All right. I'm kind of mixing this in. I'm pulling in some chapter 1 in here with this because you'll have all kinds of factoring on there when we factor completely, and I need you to recognize the difference in the 2 patterns, okay? And I put this up here because I want you to realize that I can do a difference of 2 squares. I can't do a sum of 2 squares, but I can do a sum or difference of cubes. Cubes, the sign doesn't matter. Squares, it matters. So that's really what I'm trying to drive home with you. Let's do another.
This is that last one you did is a difference of 2 squares.
Yes. Let's do
Have we done a difference of 2 squares before? wait, it's the difference of cubes, right?
No, that's the difference of squares, Grayson. All right, look at this one. Shh. Guys, I feel like I'm fighting y'all to pay attention. Y'all usually don't do this while I'm teaching. All right. Here, I don't see a pattern right off. Do you see why? Because I've got a 5 and a 2, right? Those are not squares and they're not cubes. There he is, right? Are you trying to find a GCF? I apologize. Which is the first thing you do? Did you find it? 2? Actually, do 7 to the 3rd on your calculator. What's 7 times 7 times 7? 343. Darius, what'd you get when you divided 686 by 2? All right. 2. How many x's can you take out of both of them? What's left? If you divide, remember, divide the numbers, subtract the exponents. 8x to the 3rd plus 'Does everybody see where those numbers are coming from? Okay. The biggest number, this is what Darius was plugging away at back there. The biggest two numbers that you can divide 16 and 686 by are 2. That's the biggest thing that'll go into both of them without a remainder. Okay? Then I look at the x's. This one has 2 and this one has 5, so I can take 2 away from both of them. Do you see that? So if I take 2 away from both of them, so I'm going to divide both numbers by 2. 16 divided by 2 is 8. 686 divided by 2 is 343. Then I'm going to take 2 x's away from everybody, and it leaves me with 3 and 9. You see it now? No? Do 16 divided by 2. 686 divided by 2. And I can't divide by anything bigger, I'll get remainders.
Not be factored.
It can be factored. Now I can factor because look at this pattern. What do you notice about both of those numbers? They're perfect cubes. They're on the board, right? They're special numbers.
8x and 7.
Close. 2.
Oh, yeah.
That's okay. All right, look. Little parenthesis, big parenthesis. Signs inside are what? Plus, minus, same change plus. Same change plus.
What's the first thing that you're changing?
The sign inside, you look at the original sign. So same, then change it to minus, and then the last one is plus regardless.
Is it 2 or 2x?
2x. Since it's got 3 x's there, I need to include the x.
That 3's come back here.
That's correct. That's correct.
So it always goes outside.
It always goes outside. How about the second spot in the little parentheses? 7. Okay. Now what? What goes in the first spot here? 4 what? How about the last spot?
How is that 4x?
You square, yeah, you got to square both because when you square it, it's saying 2x times 2x, which is 4x squared. What goes in the middle? Do you think you can recognize the pattern enough to plug and chug? Some of you are saying no. You want to do another one?
So like when it's plus, it's like
final answer.
Sometimes they have a GCF and sometimes they don't. Guys, I need you with me. I am not done. Sometimes they have them and sometimes they don't. For example.
This is the final answer.
Yep. Does that have a GCF? A GCF? There's nothing that I can divide the numbers by with no remainder, and they both don't even have an X, so there's no GCF. What's the pattern of the numbers? And when I'm looking at two terms, I'm looking, there's only two options. They're either perfect squares or perfect cubes. What are they? Perfect cubes, because they're to the third power. So perfect cubes is when I need to set up little parenthesis, big parenthesis. That's exactly right. I'm going to go ahead and do same, change, plus. And you said X and 6 go in the first spots, and that's correct. X squared goes in the next because you square the first. In the middle, you put them together. That's right. So you see, the ones without coefficients now are easy for you that you know the pattern. Is it the coefficients that are throwing you when there's a number in front? Nope. Leave it, but it's still part of your answer.
But if you